Hello students, how are you? Certainly fine. Students, welcome to Mathlearn, and we are doing that triangles and congruency in triangles of class 9 from Concise Mathematics Selena Publications. Already we have completed part 1 and part 2 in this chapter. Today we will be doing the final part, part 3, from question number 8 to 15. So, are you ready? Let's begin. Question number 8, we will do if AP bisect angle BAC. So, let's make an angle BAC. So, BA will be the vertex and C, and AP is the bisector of this angle. If you understand what is bisector of the angle, that means this angle is equal to this angle. This complete angle BAC is getting bisected by AP. That means AP. M is any point on AP. M is let M take M any point on AP. Prove that the perpendiculars drawn from M to AB, perpendicular drawn from M to AB. Okay, let's draw a perpendicular and AC from the same point M are equal. Okay, let's label something MN and ML. Suppose MN is perpendicular drawn on AN, that means AB, and ML is the perpendicular drawn on AC. And we have to prove that these perpendiculars are equal. So let's write what are the things given. Given AP is the bisector of angle BAC. How you will write? Angle BAP equal to angle CAP. See, we will not write AP bisects angle BAC. You have to write in mathematical term so that you understood that AP bisects angle BAC. That means this angle BAP is equal to CAP. Prove that the perpendicular is drawn. That means perpendicular is drawn. That means when MN, you can say MN and ML are perpendiculars on AB and AC. So angle ANM, this angle, and angle ALM are 90 degree because they are perpendicular. So this angle will be 90 degree, and you have to prove these perpendiculars are equal. That means MN equal to ML. Now you have to give the proof. So it's very natural that you will pick up these two triangles AMN and AML in triangle. Why I am taking these two triangles? Because only these two triangles are there, and if you one side is MN and other side is ML, if you prove these two triangles congruent and fortunately this becomes corresponding parts, then we can say that MN equal to ML. What you have to prove? In triangle AMN and triangle AML. In these two triangles, let us see. One thing is given, angle BAP. You have to think, if BAP is given, this angle, so that implies that NAM is of the same angle. What I mean, angle BAP and NAM, this is the same angle. Angle NAM equal to angle CAP or LAM are given. Because A angle is coming in NAL, if you say, and BAC, both are same angle A. These two and another one, right angle MNA equal to angle MLA. See, this angle N and angle L, both are 90 degree. If one is 90 degree, another will be definitely 90 degree, because 290 degree makes 180 degree and it's a straight line. So angle N and angle L, angle N and angle L are 90 degree. One more thing is required. Only with two parts you cannot prove the congruency. And you are seeing AM is common in both the triangles. So AM equal to AM, that is common. Now you can find out triangle ANM equal to triangle A. N is 90 degree, so I will write L is 90 degree, so corresponding to N, L will be the 90 degree, and M is the common point, ALM. Sorry, congruent. So triangle ANM and triangle ALM are congruent. We have to see MN equal to ML. See, it is two second point, third point. It is also second point, third point. Directly you can write NM equal to LM or MN equal to ML. But still, if you have some confusion, always you can draw one ANM. N is right angle, so this N equal to L, so at the position of N you have to draw L, and angle A, so angle A, so this and this common, and this are equal, and AM equal to AM, so AM equal to AM. Now see, these two angles are corresponding and this side is corresponding. So two angles and one side, but side is not in between, so I will say angle side criteria. Okay, so triangle ANM and ALM are congruent, so MN and ML are equal. MN will be equal to ML, that is CP/CTC, and this is the thing you have to prove, and it is proved. So here it goes. Number 9, ABCD is a parallelogram. Here the ABCD is given a parallelogram, though the drawing is not, figure is not very accurate. ABL is a line segment. ABL is a line segment and E is the midpoint of BC. Then you have to prove triangle DCE congruent to triangle LBE. This triangle and this triangle we have to prove congruent. And then another two things also there. We'll do stepwise. Let us first do the first one. To prove triangle DCE congruent triangle LBE. Here I don't think anything you have to construct. Directly we can give the proof. See, ABCD is a parallelogram. So AB is parallel to DC and BC is parallel to AD. That you should keep in mind. Now, in this triangle and this triangle, in triangle DCE and triangle LBE, one thing is very clear, angle E and angle E. That means angle CED will be equal to angle BEL, and because they are in vertical opposite angles, they are pair of vertical angle opposites, what I have already explained in part number 2 in the earlier video. So you understood this angle equal to this angle. And okay, E is the midpoint of BC. So it is given CE equal to BE. It is given. You can write given or you can write E is the midpoint of BC. Now another thing is there. See, DC and AB, these two lines are there and they are parallel. DC and AB are there. These lines are parallel. And CB, this CB is this is called transverse. So this angle and this angle are alternate interior angle. They are called alternate interior angle. And since DC and AB are parallel, so the alternate interior angles will be equal. E point is somewhere here. So this way. So this angle and this angle. So this angle what? Angle DCE. Angle DCE. Angle DCE equal to angle EB, and here L is there, right? So EBL, angle EBL. Now three equal parts we got. Now let us see if it comes in any criteria or not. DC, DCE, CED, this E equal to this E, and angle DCE, that means this angle equal to EBL, that means this, and another point will be EBL, and CE CE is equal to B. So we are getting correctly all the corresponding parts. So see, two corresponding angles we got, and two sides also we got. That means angle, side, angle. So these two angles are congruent as per angle, side, angle. So DCE and LBE, triangle DCE congruent triangle LBE, proved. Now second, we have to prove AB equal to BL. Just now we have proved in one triangle DCE congruent triangle LBE. Triangle LBE. So we have to prove that BL, AB equal to BL. So can I write CD and BL are corresponding parts? So CD equal to BL, CPCTC, because CD, DCE and LBE are congruent, so I can write CD and BL are also congruent. Now CD and AB are opposite sides of parallelogram. So CD equal to AB. So for this reason, I can also write in place of CD, AB, and AB equal to BL, because you have to prove that AB equal to BL. So this also got proved. Third, we have to prove AL equal to 2DC. AL. See here, AL. AL we can write AL equal to AB plus BL. AB plus BL. AB and BL, two line segments, if you sum, it will come AL. So AL equal to AB plus BL. AB equal to BL. So AB plus, in place of BL I can write AB. AB plus AB, which gives me 2AB. But we have to prove not AB, we have to prove AL equal to 2DC. AL equal to 2DC. So AB is equal to DC. So you write AL equal to 2DC. Only you substituted in place of AB, DC. So this way you proved the third sum also. Question number 10. In the given figure, AB equal to BD. AB and BD are equal, and AC and DC are equal. And some of the angles measurements are given, like angle ABD, this complete angle equal to 58 degree. Angle DBC equal to 2x minus 4 degree. In the term of x it is given. And angle ACB is also given in terms of y. And angle DCB 63 degree, and you have to find the values of x and y. Anyway, some two triangles we are seeing, and we can establish the congruency. In triangle ABC, we will take ABC and DBC. Solution. Triangle ABC and triangle BDC. We write the parts of ABC here and DBC here. AB equal to BD given, AC equal to DC. This is also given. And BC and BC equal for the both triangles because they are BC is common. BC is common. So triangle ABC will be congruent triangle ABC. See, A will flip on D, B on B, C on C. So ABC, we can clearly see A will come on D, so it will D and DBC. DBC. And this is side, side, side. This is side, side, side criteria. Now we have to see angle DBC is given. So angle DBC and ADC will be equal. And angle ACB and DCB are equal. See, ACB is given and DCB is given. ACB, this will be equal to DCB. Angle ACB will be equal to angle DCB CPCTC. Right? Angle ACB is given y plus 15. It is given y plus 15 degree equal to angle DCB is 63. So y equal to 63 minus 15, 48 degree. You found out y equal to 48 degree. Now x, angle ABC equal to angle DBC. So angle DBC is how much? Angle DBC is 2x minus 4. So angle DBC equal to 2x minus 4. So angle ABC equal to angle DBC equal to 2x minus 4. I can write because both are equal. So both, whatever in terms of x, they will be equal. And angle ABD is given. That means angle ABC and angle DBC, if you join these two angles, you are getting complete angle ABD. So angle ABC plus angle DBC equal to 2x minus 4, 1, and another is again 2x minus 4. That means 2x plus 2x, 4x, minus 4 minus 4, minus 8. And this is the complete ABC which is given. Okay, let me write angle ABD. So this complete B angle. If you add ABC and DBC, you get angle ABD. And angle ABD is given 58 degree. 58 degree equal to 4x minus 8. So 58 minus 8, you take this side plus, and it becomes 4x equal to 66. So x equal to 66 by 4, 33 by 2. So x equal to 33 by 2. So it comes 16.5 degree or 16 whole 1 by 2 degree. So x and y you have found out in degrees when it was given actually in terms of x and y. Here is your number 11 sum. In this problem, it is said AB is parallel to FD. AB and FD are parallel. AC this side and GE are parallel, and BD is given equal to CE. You have to prove that BG equal to DF. Okay, first given AB parallel FD and AC parallel GE. And one more thing is given, BD equal to CE. With these clues, we have to prove BG equal to DF. So to prove BG equal to DF, we have to only take these things what is given. We have to concentrate on the given thing so that we can prove BG equal to DF. Now AB parallel FD. If you draw the parallel two lines, see here it is given two wings, that means AB and FD are parallel. That means this angle BEG and BCF are equal. Why they are equal? Because when the BC, like this, BC is it is called transversal. When BC is the transversal and these two parallel lines, these angles called corresponding angles. These are corresponding angles, and in case of parallel lines, the corresponding angles are equal. So you can write this angle equal to this angle. This angle CB and this is FD. So this is D. So this angle and this angle are equal. Proof: angle, this angle in this triangle you can write GBE. Angle GBE equal angle, this angle you have to write FDC. We are taking these two triangles BGE and DFC. Then only we can prove BG equal to DF, because BG is one side and DF also is side of the another triangle. You can write these are corresponding angles. And similarly, GE and AC. See, GE and AC are parallel. This is also parallel. And similarly, BC is the transversal. This line is transversal. So this angle, this angle, and this angle. That means angle C and angle E. This angle and this angle, left side, they will be equal. So F is somewhere here, G is somewhere here. So F CD, F, C, D, and G, E, B. B is somewhere here. So this angle FCD and GEB are equal for the same reason. Angle GEB equal to angle FCD. Angle FCD. They are also corresponding angle. This is corresponding angle because AB parallel FD. And this is corresponding angle because GE and AC are AC parallel GE. Hope you understood how the corresponding angles are equal in case of two parallel lines. When the lines are parallel, then the corresponding angles are equal. And one more criteria you need, angle, two angles you got, one more you think. What we can do? Or only given BD equal to CE. This is given. So if you add with BD, DE, and with C also you add DE, then see what happens. With BD you are adding DE, so it becomes BE. So this becomes BE. When you are adding BD, DE with BD, the total sum becomes BE. And when you are adding CE and DE, it becomes DC. Now let's draw the diagram of the two triangles. One is GBE, another triangle is our FDC. FDC. We have to see the corresponding sides. B and DC are equal. Angle E and angle C. For this triangle, angle E, and for this triangle, it is angle C. In the left triangle, angle B, and the right side triangle is angle D. So this way, we have seen the corresponding parts and we understood that angle and side and angle. Side is in between the angles, so we can write triangle GBE. We have to GBE congruent triangle FDC by angle side angle criteria. GBE and FDC are congruent, but we have to prove that BG equal to DF, and you can clearly see BG is corresponding to FD or DF, so you can write BG equal to DF because BG and FD, they are corresponding parts. So this is CP/CTC proved. So first one, only the trick you have to keep in mind that it was given BD equal to C. So what we did, we added the D in both the sides, to get a corresponding side. So B becomes DC by adding this D both sides. Fine. This is proof for the first one. Second one, you have to prove CF equal to EG. So clearly this you have proved they are congruent, and CF and EG are corresponding sides. So you can write, since triangle GBE congruent triangle FDC proved in one, so G or EG and CF, EG equal to EG equal to CF, CPCTC, CF equal to EG or EG equal to CF, both are same thing. So this is also number 2 you have proved. Question number 12. In a triangle ABC, AB and AC are equal. So it seems to be an isosceles triangle where AB and AC are equal. This is equal. Show that the altitude AD is median also. Okay, altitude we know. Altitude means whatever is making the 90 degree. That means we have to draw, we have given a AD perpendicular on BC. So this is 90 degree because it is given altitude. So you know it is a perpendicular line on BC. So this angle is 90 degree. So this is given. What are the things are given? AB equal to AC. It is given. Angle ADC or angle ADB, angle ADB and angle ADC are 90 degree. This is also given. You have to show AD is median also. What is the meaning of median? Median means you have to know the definition of median. Median is the any line drawn from the any vertex to its midpoint of the opposite side. Median is the line segment which joins from any one vertex to the midpoint of the opposite side. So if D is the midpoint of BC, then AD is called median. Similarly, if AC, some point is there, suppose P, and you join B and P, this also BP is another median, and if Q is midpoint of AB and you join C to Q, then CQ becomes another median. So in every triangle there will be 3 median. Here it is quite simple. It is given AD is the altitude and you have to prove that AD is also a median. So what we have to prove? Mainly we have to prove that D is the midpoint of BC. Then our work is done. So this is given and we have to prove AD is median. AD is median. You can write that means BD is equal to CD. If D is midpoint of BC and A to D is the line segment, that proves that AD is the median. So this type of sum we have done previously also in triangle ABD and triangle ACD. AB is equal to AC. It is given. Angle ADB equal to angle ADC 90 degree. This is also given, or you can write AD is altitude, and AD equal to AD common. Let's see any criteria is there or not. A, D, B, A, D, C is 90 degree, is 90 degree, 90 degree is there, side hypotenuse is there, AB equal to AC, and AD is there, AD equal to AD. So see, right angle triangle R, hypotenuse are equal H. One side is given AD equal to AD, so this is side. So this you can write very well, angle triangle ADB or ABD, whatever you should write ABD or ADB, but you have to take care the other triangle you have to write the same way. ABD, triangle ABD. You have written in this sequence, so this triangle also you have to write in the same sequence, ACD, triangle ACD by RHS rule, by RHS criteria. So once you have proved ABD and ACD are congruent, then very well you can say BD and CD are congruent parts, corresponding parts. So BD equal to CD, CPCTC, and it is proved. You can write AD is the median, or already you have proved, you have mentioned that AD is median. That means you understood that you have to prove that BD equal to CD. Question number 13. This is the figure, and in this figure it is given BL equal to CM, and BL and CM are given, BL is perpendicular on SAM, see AD and the same line AM, and CM is also perpendicular on the same line. So prove that AD is median of AD, A to D, AD is median of triangle ABC. So in the last sum also I told median means that A to D, that means D is the midpoint of BC and A is joining the midpoint of BC, so AD is called the median. So you have to prove that AD is median. That means you have to prove, on the other words, BD equal to DC. So let me prove. Given BL equal to CM. Not only this, it is also given angle ALB equal to angle CMD 90 degree. We have not done by construction, it is given in the question. So in the question, whatever symbols are given, these are valid for the question, so these are given. And you have to prove, AD is median of given triangle. That means D is the midpoint of BC, or BD equal to CD. Now let us take this BL equal to CM is given. So BL and CM are given, and we have to prove that BD and CD are equal. So definitely I understand that BLD and MCD, these two triangles are required. So for the proof, triangle BLD and triangle CMD. CMD. BLD, why we have taken BLD? Because BLD is the 90 degree and CMD is also 90 degree. So we are getting some criteria. Not only that, BL is equal to CM. This is also given. So two criteria we are getting ready-made. BL is equal to CM, right, given, and angle BLD equal to angle CMD 90 degree. One more criteria is very clear here. We have discussed many times. This is the L, this is the M, this is the B, and this is C. So these two angles are called vertical opposite angle, and this point is D. So angle BDL, whatever you can say, LDB, only D must be middle. Angle LDB equal to angle CDM or MDC. MDC, and you have to write vertical opposite angles. Right? VOA or full form of vertical opposite angle if your teacher in your school doesn't like it. Write fully vertical opposite angle. Here I am writing in short form. So let me see two triangles. Let me make the corresponding. L is the 90 degree. Here M is the 90 degree. BL equal to CM. So this will be BL and this will be CM because they are equal. Now another point is here, only D, and here another point CM, D. D and D are equal. This equal to this 90 degree and this 90 degree. So though it is right angle triangle, but it doesn't fall in the category of RHS category, but it is two angles and one side. So you can write triangle DLB equal to angle DMC, angle side, angle side criteria. So once you have proved this triangle and this triangle are congruent, then definitely the BD is here and DCD is here. So BD equal to CD, congruent CD, because it is CP/CTC. BD equal to DC, so definitely it is median, right? So it is proved. Question number 14. In this figure, it is given AB equal to AC. So again it is isosceles triangle. It is a isosceles triangle. ABC is given. And AD is perpendicular. Again, AD is perpendicular. AD is perpendicular. That means 90 degree. B bisects angle B. That means total angle B is bisecting. That means this angle equal to this angle. Okay. And EF is perpendicular on AB. Diagram is okay. Proof BD equal to CD. You have to prove BD equal to CD. That means almost, yes, not almost, it is exactly AD is the median. You have to prove the AD is the median. Already you have done it in some. So first one, we can say AB equal to AC. It is given AB equal to AC. AD equal to AD. You can say in these two triangles, in triangle ABD and triangle ACD. In ABD, AB, and in ACD, AC. They are equal. In triangle AD, and they are common. And angle ADB, and angle ADC, both are 90 degree. So this is right angle, this is right angle, R. This is the opposite of right angle, hypotenuse. Hypotenuse are equal. And on side also, AD equal to AD. So RHS criteria, I can write triangle ABD congruent triangle ACD. So BD and CD are corresponding sides. So CP, CTC, and it is proved. BD and CD are corresponding parts, so they are equal. What you have to say in the first one, you have to prove that BD equal to CD. It was quite simple. Next, proof ED equal to EF. ED equal to EF. Now I can draw this line B, E is here and D is here. So this is 90 degree. EDB is 90 degree, and again this angle equal to this angle, and this is 90 degree. This is 90 degree, and this is F. I did the same thing FEDB in a separate place to clear it. So there are two triangles BFE and another is BDE. So here also, if we prove these two are congruent, then we may able to prove FE and ED are equal if they become corresponding parts. Let's try. Number 2. In triangle BFE and triangle BDE. BFE and BDE. Angle is given, angle FBE, angle FBE equal to angle DBE. DBE. Why? Because you can write given BE bisecting angle B. Here angle B means total angle. See, total angle is this angle B. So B is bisecting angle B. That means angle ABC is getting bisected by the line BE. So FBE equal to angle DB is given and angle BFE, angle BFE equal to angle BDE, both are 90 degree. See, BFE, this is 90 degree. If this is 90 degree, this also will be 90 degree. And this 90 degree, so BDE also 90 degree. They are also equal. And B is what? B is common in both the triangles. So BE equal to B, and you can write they are common. So triangle, I can see two right triangle. So one is BFE, F is right angle, and here D is right angle. So D is right angle. And angle B equal to angle B. So if you write B here, you can write B here, because they are equal, so they must be corresponding. So BDE, BDE, and BFE, BFE. So these two are congruent by which criteria? B equal to BE equal to BE, and this angle, angle, side. They are angle, side. Triangle EFB and EDB are congruent by angle, side. And you have to prove that, you have to prove ED equal to EF. So ED is this side and EF is this side. Both are falling left side. So they are corresponding. So triangle EFB congruent triangle EDB. So EF equal to ED, EF equal to ED by CPCTC, and that you have to prove. EF equal to ED, that is proved. So this is number 2 and that was number 1. Question number 15, and this is the last sum in your exercise 9A. Using the information in the given figure, you have to prove AB equal to FE and BD equal to CF. AB equal to FE. AB equal to FE. Okay, let's prove the first one. AB and FE. So by this time you understood we have to take this triangle and this triangle, because AB is part of ABC and FE is part of this triangle. So you have to identify these two triangles. In triangle ABC and triangle EDF. One angle is given, angle ACB equal to angle FDE. FDE. This information is given, so I can write it is given in the figure. Now another AC side is given equal to D side. So now we have to get third one. Third one, you can take the same AB. This AB is parallel to this line FE, and we talked if something is transverse, then this angle is this FE and this angle and this angle. This line is parallel to this line. So this line is transverse. So this angle and this angle becomes alternate interior angle. So angle ABC will be equal to angle EFD. F is here, B is here, B, and F is here. That means this line is the transverse. So this angle and this angle, and E is here. So this angle and this angle are alternate interior angle. These are two parallel lines. So interior angles are this 1, 2, 3 and 4. The angles formed between the parallel lines are called interior angles. So 1, 2, 3, 4 are interior angle. If I take this angle, then alternate angle is angle 3. So here you can see angle ABC and angle this. These are two alternate interior angle. So angle ABC and angle EFD. You can write alternate interior angles. Now you know ABC and you have to say DEF. Let us see what are the corresponding parts to whom. This C is corresponds to D, so you have to write D. B, this one corresponds to F, so this becomes F, and EFD, so this is the remaining one, E. And one more AC, AC is equal to DE, AC equal to D. So by triangle ABC congruent triangle EFD by angle side criteria. You have to prove that AB equal to FE, AB and FE, two are corresponding sides. So easily you can say AB equal to FE, FE say or EF, line segment, you can say both. So this is CP, CTC. First one is proved. And BD equal to CF. See, we have, okay, BC and FD are equal. Okay, we can write BC equal to FD. This is also CPCTC. BC and FD are corresponding. Now, if you subtract this DC, both the sides, FD minus DC, what you are getting? From BC, if you are subtracting DC, then you are getting BD. So this becomes BD, and similarly from FD, if you are subtracting DC, then you are getting CF. BD equal to CF. You can write by subtracting DC from both sides. So BD equal to CF, what you have to prove? It is proved, and this way you have proved both the things. Hope you have enjoyed complete chapter of the congruency in triangle. If you have liked the video, please share with your friends and give a like and give your own comments.